Take a look at this math problem. We have a system of equations, a linear equation on top, a quadratic on the bottom, and a question asking how many ordered pairs satisfy both. The obvious instinct here is to try and calculate the exact x and y coordinates. Do not do this. Attempting to solve for the exact coordinates is a massive waste of time on a standardized test. Instead, we can find the total number of solutions without ever knowing where those coordinates actually are. We do this by combining the equations and using a specific piece of the quadratic formula. On a timed exam, recognizing what you don't need to calculate saves you just as many points as knowing the right formulas. Step 1 is merging these two separate lines into a single solvable equation. We will do this using substitution. We take the entire expression for y from our second equation and drop it directly into the y position of our first equation. But right here is where most students make their first critical error. If you drop that expression in without wrapping it in brackets, the math falls apart. Those brackets are essential because the leading 2 needs to eventually multiply against the entire expanded quadratic we just substituted in, not just the first term. With the equations properly merged, we have eliminated the y variable completely. We now have a clear single variable path forward. Now we need to clean up this merged equation, starting with expanding the binomials inside our brackets. Using the FOIL method, multiplying the first, outer, inner, and last terms, our two binomials become 2x squared plus 15x minus 27. Next, we distribute that leading 2 across our new inside terms and add the positive 5 at the end. This gives us x equals 4x squared plus 30x minus 49. Here is another trap. You might be tempted to define your a, b, and c variables right now. If you do, your final answer will be wrong. To use quadratic formulas, the equation must equal exactly 0. So we need to subtract that lone x from the left side to move it over to the right. That leaves us with our final, correctly formatted equation. 0 equals 4x squared plus 29x minus 49. Always remember, forcing the equation to equal 0 is the strict, non-negotiable prerequisite before you can apply any quadratic shortcuts. Now we can bring in our shortcut, the discriminant formula. This is simply the b squared minus 4ac portion of the quadratic formula, the part that lives under the square root. The discriminant has 3 strict rules based on its outcome. If positive, you have 2 solutions. If it equals 0, 1 solution. And if negative, 0 real solutions. Looking at the standard form equation we just built, we can identify our variables. A is 4, B is 29, and C is negative 49. Pay close attention to that C variable. Dropping the negative sign on the 49 is a fatal calculation error, and it happens frequently even in official study guides. This image is a screenshot from a provided solution guide. Notice step 3. The guide correctly identifies the formula, but completely drops the negative sign on the 49 during the calculation. Let's execute the correct calculation. We have 29 squared minus 4 times negative 49. Those two negatives multiply to create a positive, giving us 841 plus 784 for a sum of 1,625. 1,625 is a positive number. Because the discriminant is positive, the rule mathematically guarantees that there are exactly 2 real solutions to this system. Let's return to the multiple choice question that started this entire process. The problem asks how many ordered pairs satisfy the system. Based on our discriminant result, we know the answer is definitively C, 2. We arrived at this answer without ever drawing a graph or calculating a single exact coordinate. We simply proved exactly how many times the line and the parabola intersect. Memorizing the 3 discriminant rules allows you to bypass brute force calculation entirely. It is a highly efficient strategy to save critical time on standardized tests.